Hi everyone. Hope you are all having a wonderful day. Welcome to today's meetup session on deep dive into auto scaling with Apache Flink. So this event is hosted by Data Couch and Confluent together. And today we are honored to have our SME Samrat Dev as our instructor for the session. So Samrat will be focusing on how we can leverage the Flink autoscaler for managing dynamic workloads. Before we start the session, let me quickly take you to a very quick introduction about Data Couch, the company that I represent. We are leaders in professional service delivery, specializing in agentic AI, generative AI, data engineering, cloud, blockchain, NFT, cybersecurity, and many more advanced Web 3.0 technologies. Our service bouquet includes consulting and implementation services, upskilling and reskilling, and enablement solutions that are all supported by a proprietary browser-based virtual app solution. We also offer managed services for infrastructure and human capital to meet unique requirements of organizations of all scales and sizes. We are excited to share that our global footprint has enabled us to transform the careers and lives of over 200K professionals, 200,000 professionals that is. Thanks to this growing community of learners, our expertise now spans cutting-edge technologies where we continue to push the boundaries of innovation. We cover over 50 advanced certification courses, have tailor-made courses and learning paths in domains such as Web 3.0 technologies, generative AI, agentic AI, big data, data engineering, DevOps, cloud, and more. We have a network of over 500 industry expert practitioners that are certified and vetted by giants such as Confluent, Snowflake, Cloudera, Google, AWS, and more. So, highlighting our significant achievements, we have successfully partnered with Fortune 500 companies and global system integrators or GSIs. That includes the biggest names such as Infosys, Accenture, and TCS. We also are partners and routinely deliver training at companies such as Apple, Salesforce, and Google. Many multinational corporations such as PayPal, PepsiCo, Bank of America, Visa, and Blue Cross and Blue Shield are among the other corporations where we have left our footprints. Driven by a commitment to community and knowledge sharing, we have established 3 specialized meetup groups, that is AI Minds, Generative AI User Group, and All Things Data. With a combined membership that exceeds 27,000 users, our community has participated and hosted 200 such sessions that we are attending now. These have covered more than 100 diverse technologies and tools so far. Looking at our commitment towards technology as well as knowledge sharing, we have been honored as the first training delivery partner for emerging technology giants such as Starburst Data, Bunhouse, and Kering. And we are proud to forge and build upon strong partnership with industry leaders. While some client names remain confidential, our collaborations include a global beverages and snacks multinational, a premier North American payment solution provider, a cutting-edge cybersecurity and risk management platform, and a retail giant whose operations span across 5 continents. We are also an authorized training reseller for Snowflake for their official courses, like the widely popular Snowflake Fundamentals for the SAARC region. You can reach out to us to get these official training programs delivered by Snowflake instructors at exclusive discounts. Now, coming to our relationship with Confluent, we have been a global education delivery partner for Confluent for the past 7 years. And of those 7 years, we have been recognized as the only company to be recognized for the award of Global Education Delivery Partner for the years 2022, 2023, and 2024. This recognition, received for the 3rd consecutive year, underscores our leadership in providing cutting-edge training and consultancy services on a global scale. Now, a few words about Confluent. I hope that everyone who has joined this particular session on Apache Flink already knows about Confluent, but just to give you a brief introduction. So Confluent is a leading data streaming platform that was founded by the original co-creators of Apache Kafka. It enables real-time streaming, connecting, processing, and governing of data, turning complexity into actionable insights. With integration of Apache Flink's powerful processing capabilities, it handles complex event-driven analytics at scale. Confluent's cloud-native solution manages over 30,000 clusters, 3 trillion messages per day, and more than an exabyte of data every day. Major clients include Walmart, Expedia, and Goldman Sachs that trust it to build faster and smarter data systems. Confluent provides a powerful data streaming platform, enabling seamless real-time data processing across your organization. Stream events effortlessly through its cloud native engine, connect quickly to diverse third party sources, and govern your critical data securely. Integrated with Apache Flink, Confluent accelerates your projects to production in just 6 months, guarantees a remarkable 99.99% uptime across multi A to Z clusters, and deliver billions in savings on engineering and operational costs. By combining Apache Kafka and Apache Flink, organizations benefit from unified stream and batch processing, significantly simplifying complex data pipelines. This synergy provides exactly once processing guarantees, ensuring fault tolerant and reliable data handling, which is very crucial for mission critical applications. Kafka's powerful event streaming capabilities paired with Flink's rapid in-memory processing deliver outstanding throughput and low latency that allows this combination to manage millions of events per second. This scalability enables advanced real-time analytics, powering use cases such as fraud detection and personalized recommendations. Moreover, their seamless integration and flexible APIs empowers developers to effortlessly connect diverse systems, accelerating innovation and enhancing versatility. So this was a brief introduction about not only Data Couch, but also about the Confluent and the tools that we are about to touch very briefly upon from now. So before I begin, let me introduce to our speaker for the day. Samrat, I would request you to please turn on your camera.
Yeah.
Thank you very much. So we are excited to have Samrat Dev, a senior software engineer at Confluent, joining us from Bengaluru, India. In his previous stint, Samrat has worked as SDE2 at AWS, SDE2 at Disney Hotstar, and GoIBibo, among other. Samrat is a driving force in tech world with deep expertise in distributed systems, durable applications, and real-time data processing. And as an Apache Flink committer, he has left his mark on open source community, enhancing the tools that power cutting-edge sources solutions globally. He's a respected contributor, collaborator, and innovator. And here's a fun tidbit about Samrat. He has once sparred through a 5-hour coding marathon to squash a critical bug armed with nothing but coffee. And today he is here to share his knowledge and experiences. So please join us in giving him a warm welcome. You can use emoji or thumbs up to start the session. Samrat, over to you. Thank you.
Cool. Hello, everyone. Today we are here to talk more deeply and understand, right, how actually Flink is, what actually the Flink is, and then shift our looks on how Flink as an application can be scaled without manual intervention. You can scale it if your data ingestion is high. You can downscale it based on policies, but it is like automatic in nature, and Flink Autoscaler plays an important role in deciding what is the next parallelism or next future by predicting based on matrices and all those stuffs. So before we get started, how folks are acquainted with Flink, Apache Flink, or stream processing? Please give like maybe a message in the chat or emojis so that I'm aware of. Cool. Awesome. Yep. Cool. So I'll start very briefly, right? So I'll skip this thing because already introduced. Yep. So just a quick recap, since this talk is more about how auto scaling things works for Flink. So based on like Flink, what is Flink is a stateful computation over your data stream. So data stream is nothing but your real-time data that is either generated by your user or some uh, system that is in the downstream applications or upstream application that wants to feed into the uh, uh, like uh, application of Flink. There are two concepts associated with Flink. One is bounded stream and another is unbounded stream. So bounded stream is something like you have a start point and end point of a stream. Basically, events. So for example, any file, right, is a bounded stream because you have a start point to it and an end to it. Every file needs to be closed. That's why it is a bounded stream. So this is one aspect of it. An unbounded stream is something you can assume it to be your web application, your user continuously interacting with it. It is all dynamic in nature, where you actually don't know how user will behave when they will generate a new event or they will perform a new action in your application. So that's where this unbounded stream concept comes in. And Flink says that, hey, I will work with your unbounded stream. I will be continuously processing your data as soon as it is being created or it is being produced. We'll process it based on the logic defined by the user. So that's where the bounded or unbounded stream concept comes in. So I assume this is clear to you guys, right? Please raise hands if you have questions or doubts. I'll help you to understand those stuffs. So moving on, right? Once we have covered this bounded, unbounded stream, now what is meant by stateful processing? So stateful processing is, for example, like if you take an example, you need to process some data, and that data, while processing, you need to keep some intermediate data or logically derived data that is partially moving towards the correct solution. For example, like, right, you have a window function. So since Flink works, or like Flink framework or stream processing is based on a real-time unbounded stream, you are not aware about mm, Uh, Deepak, Flink does not, yes, Flink internally treats bounded stream into a unbounded, but not the other way around that you know about. So Flink treats every event as a unique event, and then the operators works on the top of that event to generate a new event for the downstream operators in the DAG. Okay, so basically, the assume that you have some kind of window and new events are getting created, right? Let's say you are counting from 1 to 100. So in between, there would be some values at 50, 60s, right? So there is an intermediate data um, that needs to be pre-computed, so that when next event comes in, it can be pre-applied on top of it, like an edit log, basically on top of it. So that's where this intermediate stateful processing comes in. You can't just publish the data unless it is completely correct and it has satisfied some of the conditions. For our example, you need a trigger to close the window. That's where when the trigger is closed, that intermediate data gets promoted to the final result. Similarly, with other operators, like you may be doing some aggregates or a lot of other operators that SQL offers. With recent, basically, development related to ML and other stuffs, there are a bunch of data science related operators like regressions, chart filling, and also like curve fitting and all those things, where there are some triggers which leads you to store or continuously calculate the intermediate data, which is termed as stateful process, basically stateful. And event time is where actually the events or the basically the your messages carries the timestamp about themselves, or like when they are generated, when it was actually created by the source, is being carried or basically inserted into as a one of the attribute in the message or the event. So that's how it is. So Flink has now recently developed from Flink 1.16. It has come up with a batch processing as well. So batch processing is nothing but stream processing, which has its finite start point and finite end point. That's where the batching is defined. If you reach the end point, or like the condition that defines the end point, there the application gets closed and it says that, hey, I have processed this batch defined from source to the end. Yeah, Prashant, please.
Yeah, now I can. Yeah, thank you.
Great.
Hi, Samrat. Samrat, like, is my understanding correct that, like, in Flink, like, when events are ingested to Flink, these two constructs, okay, event time and processing time. So, like, user can choose like which column to treat as processing time, and event time Flink itself attaches to each and every event. Like, is that understanding correct?
No, little bit other way around. So event time is what during generation or the uh, event is created. It's on the logic of the upstream. Are they inserting that timestamp? Like for example, if I'm interacting with Zoom or like I'm doing some action in Zoom, it's on the Zoom web application. If they are attaching the timestamp, current timestamp with the event, then it is getting treated as a event time. Processing time is when actually your event enters into the Flink, basically the source operator. So source operator attaches on top of it, like a wrapper on top of it, a processing timestamp. So processing timestamp is attached by the source operator in the Flink. So the very first operator which reads from the sources, they attaches the processing timestamp. Yes, you are right on the part that it's on the application developer who is writing the Flink jobs. They can choose between processing timestamp and the event timestamp. Uh,
Got it, got it. So that means like if I have to use event time, the user should also specify which column to treat as event time. While in the case of processing time, they can specify that I want to use processing time, but the system will understand like how to get that processing time.
yes. So every message or everything in the DAG, basically, Flink is like a directed acyclic graph. So it will by default choose the processing time as the timestamp to create watermarks and making the progress of the processing.
Sure. Yeah. Thank you.
Yep. Another question I'll take from Harshit is like, what would be the key difference between Kafka Stream and Flink? Yep. So Kafka Streams and Flink has no difference basically, but it's on as a user basis. Like if you understand from the user perspective, you can do all kind of SQL or any kind of operation on the streams. Kafka streams also provide that, but there are huge differences in terms of infrastructure, scaling, so which suits different needs based on your basically business use cases. So Flink is meant for high scale. Your workload is not constant. Your workload is very spiky in nature sometimes, and sometimes it just very little events getting processed. So Flink is meant to handle those in scale, while uh, Kafka streams are built for constant workloads with minimal cost in your infrastructure and processing it within the Kafka, from Kafka to Kafka, or like more integrated with the system. But Flink comes with a wide range of connectors where you can connect with MongoDB to put in Kafka, from Kafka to some other database or RDBMS. You can read from RDBMS to put it into S3. Like so, Flink is more like a processing engine, which offers you to read from n number of sources to write to m number of sources. Cool. I'll move forward a little bit, right? So as this diagram suggests, right, you can have a lot of streams, right, which is real time generated. There can be some of your historic data which is present in your DB, maybe in your blob storage, where this Flink refers to, and you are trying to join those things, making meaningful decision out of it, and then either passing it to some other application who is trying to consume those processed data, or you want to write it into database so that other application can fetch it from the database, or you want to stream it back to the maybe Kafka as a queue, right? Or several other queues available, or you want to, after processing, you want to write it into file storage with a recent usage coming in, where you want to train your more models with new recent data, with a lot of feedbacks and real-time data feeding into your system to making your model more, train your model more quicker with the real-time data scenarios, right? That's how the Flink finds its sweet spot, or like where it sits, resides, and helps you to scale, read, process the data, and then finally make or like basically create meaningful data information based on the processing logic defined in the Flink. So Flink offers multiple layers of how you can actually define your logic, either via low-level data stream APIs, which is where you need Java-related knowledge, or basically to understand how you can pass inputs, how you process it, and then and or like creates the data for the next operators. There is, on top of that data stream, there is a table API, so which is more of like a abstraction on top of data stream API, which says that, hey, as a user, they don't want to configure at the very low level of the stream. So this table API offers a good abstraction where you just define your logic in terms of uh, functions, chaining, and you can do it. And then there is one more layer on top of this table API, is called SQL, where any folks like there are different group of people who are very comfortable with SQL, so they can define or write a SQL, and that SQL get translated into table APIs. That table APIs then get translated into data stream APIs, and then finally into a physical plan, which converts, or which actually gets distributed to your distributed resources, where multiple jobs or like multiple things runs. Yes, Flink supports for now Java and Python. Scala is on deprecation path, basically. So Python is PyFlink is carrying it's getting traction, and it's in it's in it's growing. A lot of operators are not yet offerable through PyFlink, but yes, Python is growing in the Flink community. So this language connectors are more of like so you have a core of Flink. This language connectors are more basically mapping. So they try to map it. They try to convert your like Python related code into basically some kind of uh, representation, basically compile plan representation, which actually the Flink as a framework understands it. At the end, Flink is a JVM based uh, framework, which spawns with multiple threads, multiple processes in different machines, and intercommunication between it. Yep. So I'll move forward on the next thing, right? So let's assume that great. You have a Flink application written. You have a lot of machines associated with it, but your workload patterns in your production is not always same, right? Like for example, there can be you can assume maybe a Black Friday, right, where sales would be pretty high. The number of events generated will be pretty high, and it would be needing real-time applications to scale, process more amount of data. The traffic is the traffic will be reaching its limits, and you need to do it. So at that time, you need your application to scale without manual interventions, as well as it should scale in a way that you directly don't go from, let's say, parallelism of 1 to directly to 10,000, right? You just want your application to scale step by step, so that it catches up with the traffic. Because at the peak, you can predict the peak, but it's not always the prediction that leads. Prediction cannot be always correct, right? So you can deploy it with Kubernetes, and what it says, it's like, right, you can create a custom resource in Kubernetes and just deploy it. You can have a quick recovery if any pods or any task manager starts failing. Flink can help you, like Kubernetes can help you with respawning that Kubernetes, basically task managers and tasks for you. How it really make difference on how so, Flink and Flink Cloud, how it really makes a difference on how we can just five people using KSQL DB in cloud instead of go with Yep, Neha, I'll not be the right person to answer this difference. I'm solely integrated with, basically, I'm a developer in a Flink and building features. So, right folk would be, you can connect with maybe Confluent folks who can help you with those questions. Cool. And then, Kubernetes, with Kubernetes, you get a lot of containerization support. Basically, you can, anything failed, you want a log, so you can have those container logs getting pulled into your dev system, analyze what is failing, and then recreate or like start from the CRs that is available, right? You can also optimize resources, saying that some of your operators, for example, operators like sum or aggregate, may need more of like memory rather than CPU cycle because they are adding sums to it. But some of the operators like window functions or like filter functions, they might not need memory as it is compared to the other operators, right? So you can actually define the container size, allocations, and basically productively or like efficiently use your resources. So so Flink is a JVM based application, right? It runs on the virtual machines. It can spawn a lot of processes, but you also want to run those things in Kubernetes, right? So how, as a user, right, you can just put your entire Flink application into Kubernetes. There comes this a bridge called Flink Kubernetes Operator, which is also under the Apache Foundation, right, and also maintained by Flink community. It's called Flink Kubernetes Operator. So this Flink Kubernetes Operator does this entire thing for you. You just need to write a job, create a jar out of it, put it in some storage or URI storage. You can create a CR like normal Kubernetes application deployment, and then submit it to this Flink, submit it via this Flink Kubernetes operator. So this Flink Kubernetes operator is also a JVM based application that you need to install in your Kubernetes. And whenever you want to run or create new application or modify the existing Flink application, you just submit your request to this Flink Kubernetes operator, and black magic happens basically, right? Flink Kubernetes operator takes care of scaling, changing the configurations of Flink that you have defined on your application. For example, right, you want to change your parallelism, max parallelism, you want to change basically the window size and all those things via some configuration. You want to change the checkpointing directories, checkpointing intervals, and all those things simply by updating in this Kubernetes operator with an update command, and it will be happening on the got to go. And Kubernetes operator will Flink Kubernetes operator will take care of applying those things to your dedicated Flink application, and it can also maintain hundreds and thousands of your Flink application running in your cluster. So it's more like a manager for you who helps basically to like manage all your applications without you actually going deep dive and then taking care of it manually. So till now, any doubts, or is it clear to you guys, or you need more detail in depth on a very low, newbie understanding? Okay, I'll move forward on this. So, uh, uh, so I'll move forward. So yes, let's say you have Kubernetes operator, you have uh, created your Flink job. So far, so good. You have deployed your Flink applications, right? But the problem is you can't predict your. Could you please list manager Flink provider? List manager Flink providers. Uh, Vasava, like you can search it online basically with this terms that you have, and you will find bunch of providers in internet. Uh, cool. So I'll move forward now. So far, so good. You have your Flink application running, doing great. But as we all know, right, we cannot predict the scale, the traffic patterns, actually real time that is happening in with your application. You can predict you can predict like, hey, I'm assuming 10 million records or 10 million events per second, but your product may be doing really great, your idea is great, and then suddenly you see 100 million events created by the user, and how do you scale, right? At that time, you can't afford your application to just fall, right? Fail just because you don't have any mechanism to scale your application on a fly. How quickly can Fluent create to sudden spike in Kafka? Yes, that's where we are going into basically to understand how actually the Flink autoscaler algorithm works. That will answer your question at the end, Taranveer. So just hold tight. Mm. Uh, so cool. Right, and even right, as a user or application developer, we don't want um, uh, to be always in front of your application, monitoring application, ideally changing the parallelism, or ideally changing the scale size, how it can traffic you can handle within the application. So there it comes called for auto scaling. So what if your Flink Kubernetes operator can support some kind of plugin? This plugin, for example, like the plugin has some functional requirement that, hey, based on the scale I see in the input, you define what is the best suitable parallelism as well as resources I need to process that input or incoming pressure or data that is coming into my source connectors, uh, as well as that black box of auto scaling should also know in between the number of operators, right? You can have source operators, they can do some filter logic, and then they can do some mapping, and then some windowing, and then finally to the end of the like some writing it to some another sync connectors. But all of these operators will operate at different speed, right? For a window will, if you have defined a window of size 10 minutes of window size, then it is always true that that window will always produce a new event after the 10 uh, 10 minutes, right? Whatever the interval is defined. But it is but it's functionality is different from maybe a filter operator, which just checks some Boolean or logic or some at the end, which computes to true or false, and then it allows it to pass or not. So if you see different operators operate differently, their functionality is different, but at the end, they are similar on a logic that they will take input, or like they will read some or modify or read some events, and at the end output some events at the end. So how you can, so that auto scaling comes in where right, it tries to identify what would be the next best suitable parallelism for my current incoming request or current ongoing events that is coming into my source operators. How can I dynamically manage those workloads so that it can consume it? At the same time, considering that resources are limited to me, or whenever like on a fly I get new resources, free resources, I should be able to utilize it, and also cost efficiently, to not just basically use that resources unnecessarily, right? At the same time, if the workload is reduced, it should be able to releases the resource so that other applications in the clusters can use that. So I'll take question from Shivam, is like, considering Kafka partition-based architecture, how does Flink Autoscaler handle rebalancing stateful computation without losing state or introducing? Yeah, it's a property of connectors, basically. So you might be aware about Flink connector to Kafka, basically. So whenever a Kafka topic registers as a source, it has a finite partition size, right? And also in Kafka, changing partition is not online. Basically, it needs a downtime where you need to rebalance it and all those things. During rebalancing, the Flink just tries to read from the existing partition if it sees that, hey, there is a change. And it also periodically checks or calls a heartbeat, it basically tries to call maybe the brokers, basically it tries to call the brokers with the metadata information about the topic. And once it sees that there is a difference in the topic, it tries to rebalance it. I think this is available from higher version, recent version of Flink connector to Kafka, but initially it was like once the job start, whatever is the metadata information will be used. So in case in between the Kafka scaled up from 5 partition to 7 partition, it won't be able to read from other 2 partition, but now it can read basically with the recent developments in Flink connector to Kafka. Can you discuss real world studies or example where, yes, we'll discuss it at the end, maybe on a brief, but yeah. So yeah, we discussed, right, like that we need some kind of smart auto scaling logic or some algorithm that should be able to help us with uh, dynamic workload management, resource optimization, and cost efficiency. And it should not hit some kind of SLAs and all. But if you look at auto scaling, right, there are challenges that auto scaling needs to handle under the hood as a deep module. So it needs to say that resource shouldn't be underutilized. Let's say auto scale to very high value. It has requested for hundreds of task managers, but most of them are sitting idle. So autoscaler should also take care of disposing or releasing the resources which are not required. It shouldn't be very conservative in nature, so that it just asks for 5 or 6 auto task managers, but actual requirement is maybe around hundreds. So it should not create a performance bottleneck as well, right? And then it also helps with suddenly, right, as a user, you say that, hey, autoscaler is not doing great. I just see that my workload patterns will just next 5 minutes, I see it will increase by a shoot up. So I should, as a manually, you just trigger to the next higher, basically parallelism value. So autoscaler should also not just take care of this thing, also it should take care of manual scaling and also adapt to those manual values. It should not again pull it back to the lower values as well. And also, right, oscillations. So there is a concept, right, like when you do auto scaling, since it's a distributed system, you need to take care of fault tolerance, consistency, and data shouldn't be lost. There are some performance hit in auto scaling. Basically, when you scale up or down, your jobs get paused for few interval of time, or like small interval of time. We'll discuss it in detail why that pause happens. So more frequently you are doing auto scaling, that means your job is not progressing. It is busy taking care of operational task of scaling up, scaling down, taking checkpoints of what is processed till now, and all those things. So it shouldn't be oscillating in between. So these are like challenges that autoscaler is trying to solve. So we'll go deeper into it. Right. So this challenge is basically solved, right, by plugging in this autoscaler into the Kubernetes, right? And the Flink Kubernetes operator itself has a submodule called Flink Autoscaler, which can be plugged in with your Kubernetes operator. You can plug in with your Yarn if your Flink is running in Yarn, or if you are running your Flink in Mesos as a resource provider, then you can also plug in this thing. So this autoscaler is more like a plugin stateless application, which I'll not say at stateless, but yes, it just uses some storage integrates with it. I'm not sure, Sunny, if it is integrated with Keda, but open source Flink supports only Yarn and Kubernetes basically. Mesos support is deprecated, but KEDA I'm not aware of on that part. Yep. And also, right, like dynamic resource allocation, you can also say that, hey, I know my user uh, patterns or my input data pattern. I want to define some policies. I want to define some policies which should be taken into account while auto scaling or while deciding the next parallelism for the Flink application to scale, or you want to downscale it, when to downscale it, and all those aspects. Any question till now on like why we need auto scaling, where this auto scaling as a framework fits in, and what are the use case that it supports basically? Oh, I'll move forward basically. So now going into I'll go deeper into how auto scaling mechanism works. So autoscaler comes with a simple public interface, right? It says that rescale with some matrices, basically just give me the job ID of your Flink application. I'll take care of knowing this. This is the only the user interface that it has, and auto scaling policies and all get supported basically during the uh, policies which gets invoked when you initialize autoscaler, or when you initialize the Flink Kubernetes operator with a plugin of auto scaling mechanism. So you get a trigger condition for scaling. For example, this trigger conditions can be, right, hey, new resources are available, right? You get to add it more resources in your Kubernetes infrastructure, or you get more resources available in your Yarn clusters, basically. What strategies that Flink employs to ensure exactly one semantics during autoscaling, especially compared to Spark structured string? Yep, we'll discuss this, right? Once we close this autoscaling mechanism, basically how it actually works in code basis, basically in low level. So it gets a trigger mechanism, trigger condition for scaling. Once the trigger condition is received, uh, uh, auto scaling in Flinks basically just looks for a few matrices. These matrices are like back pressure. Basically, every operator in the Flink sends periodically the matrices, matrices to the uh, Kubernetes operator in the CR or in secrets. You can configure that. It just writes into a log file, or you can configure any JDBC or database behind the scene, or you can put it in the in memory as well. So how it does it's right, like it looks for source back pressure, TTL, basically what is the maximum what is the average processing time for each operator, what is the follow up, or like what is the queue buffer queue is filling up for each operator. It continuously reads those matrices. These are all 6 matrices that it uses. Once these matrices are used, you define, so as a user, when you configure your Flink auto scaling and Kubernetes operator, you define few of the configurations. These configurations are basically so it looks for indicators like, right, busy time percentage, like how much time is your operator is busy, and how much time it is busy processing actually the records, and how much time it is taking to send matrices from the operator or task slots, basically. Then what is the data rate of incoming, and what is the data rate of output? Basically, your sync operator writes to any external system, right? So what is the rate at which it is writing, and what is the rate at which the input is coming, and backlog size of each buffer on the each operator, and the backlog growth rate. So per second is the backlog growing, and all those things, and the source parallelism, right? Your entire Flink job application, scaling depends on how many source operators are basically running for your sources. It is highly dependent on the external system from the source you are reading. For example, if you are reading from your database, you might not want to increase the scale because it can lead to rigorous reading, and it can take your database down, if it is your sync replica, or if you are reading from the master. So you want to limit the rate at which it wants to read. So all those things are taken into consideration. So there are three type of reconcilers. So this Rescale API, it comes with a wrapper over it. It's called application reconciler, session reconciler, or job session reconciler. So application reconciler is specific to application mode Flink deployment. If you are deploying your Flink application in application mode, basically that, hey, if this application fails, it should not affect the other jobs running in that, where you have entire dedicated resource given to one application at one time. There is a second type of cluster you can define for a Flink, is like you define it as a session cluster, where you initially just spawn up a job manager, then you try to submit multiple application to that session, so session job manager, so that you can have multiple uh, basically multiple basically application running using that job manager, and manage and all managed by job managers. So it comes with a so session reconciler comes with a lot of one more internal class, which is called session job reconciler. So per session you can have n number of jobs. So every job may not need to rescale, right? You can have few requirements where one or two jobs want to rescale up, few jobs want to rescale down. So how do you take care of this? So that's why we have this three type of reconciler. This is not configured by user. It's just defined on fly, because your application details or application metadata led to the selections of which reconciler to use at a time. Cool. What strategy does Flink employ to ensure exactly one semantics? Okay, I'll take on that on afterwards. Does Flink offer native monitoring and visualization tool for? Yes, Flink has a Flink web UI. Basically, every application comes with a Flink web UI, where it has a good details of your every task manager, task slots, and all those things. All these matrices are handled by your stream execution environment, or basically the execution environment. Your execution environment can be of different type, like stream mode or batch mode. So if you are using stream execution mode, then streaming, basically then it gives you stream execution mode. It behaves differently than batch execution mode, basically. So basically it offers you some API or endpoints where you can pull in. So Flink Web UI is in a pull mechanism where it requests for the matrices, and whenever the your operator and task slot is free, they respond to this. It's a more of like a long pulling mechanism in between, where as a web UI client, it requests for a matrices, and it waits for the long time until the operator or the stream execution address or like responds to it. This is because your streaming execution can be busy processing your records. So priority is processing your job or real-time data rather than offering so the first class citizen is your processing, then comes the monitoring aspect and observability. So yes, Flink comes with a Flink web UI, and it's a like clean and beautiful UI where you can navigate to all the operators, look through the graph definitions and all those things. Um, so right, so since we discussed this auto scaling, so whenever there is, let's say, based on this configurations, right? And how do you take decision? Now you'll ask that, hey, you have collected all the matrices, you are getting the matrices in a pooling way. Now, how do you decide on, right? Should I scale? What values to be? What should be the next parallelism value based on this data? So you have raw data you need to process, right? So autoscaler processes it combines it joins it, and then it reduces it to some of the values. So right, so these values, once it is created, now it gets compared with few of the configuration that user basically needs to basically user needs to set based on which autoscaler will take decision or trigger this thing. So one is like you need to enable your autoscaler. By default, it is not enabled. So you have to pass in, right? You have to configure this Kubernetes operated job autoscaler enabled, right? And so once you have enabled, you need to also define, right? Like it shouldn't be like, as we talked about oscillation, right? Your job shouldn't be always scaling up, scaling down, right? It shouldn't be busy in those more on this thing, rather than it should focus on actually processing the data, which is the core like goal for the entire application. So you define that, hey, like do not auto scale anything or scale my job, at least give the difference of this event. Like you can define this interval to be 5 minutes, 10 minutes, and all those aspects, right? And one more thing is stabilization interval. Once you scale up, right? So your job will be check. So how rescale works is like you will have to first take the checkpointing of the running job. Once the checkpointing is done, the job is paused, basically, right? All the operators get killed. Then with the new parallelism, the job gets restarted with an adaptive scheduler. Basically, the adaptive scheduler says that, hey, until I reach the maximum parallelism, I'll keep on seeing or like accumulating the resources for the job. So here, this stabilization interval, you say that, hey, if you have scaled before, like, right, some time ago, at least give some cool off time so that my job can progress something, right? So do not do uh, any actions, right? Or do not even like try to accumulate or compute on the resources, even the matrices, so that I can totally focus on processing and moving the job or application, uh, catching up with the um, input data. And then you give the metrics window to it, right? That minimum within this metrics window, you should be calculating the computing, do I need to scale or not, right? Then Flink autoscaler also gives the like liberty to the users, right, to define, right, how their utilizations can be understood. So they can give target, what is the min utilization they are looking for, what is the max utilization. Based on max utilization, if it says 70% of the max utilization is reached, then try to scale it, because I don't want to reach 90%, 95% until I get memory out of bound or my job is completely stuck. So if this 70% is reached, try to scale, right? Try to trigger the scaling activities and all those things. Yeah, again, right, for the job operators and windows and kind of step. And the autoscaler, right? In autoscaler, it takes the past information of the metrics collected. So you can define, right, up from current time to backward time, how much time I should consider matrices that I have collected, consider 1 hour like behind matrices to consider for my scaling. Consider for the pattern, fit the curve. Like, do I see the scale to be go down based on last 1 hour, or do I see it needs to be increased? So that's completely dependent on user to define it, and they can pass in those things, so that their autoscaler can be configured based on the use case for it. And the maximum count comes with the same thing, right? And also for the scaling configuration, so these are like scaling configuration cool off time, so that your autoscaler can complete do the new parallelism, calculate the new parallelism out of it. And the autoscaler works in some of a manner, right? When a rescale API is triggered with new parallelism, first the checks happen, right? If the resource I can acquire. So it first acquires the container that it needs. Once it acquires the container, it triggers the next activity, which is called checkpointing. So at this thing, every operator get checkpointed via like a checkpoint barrier will be inserted by the job manager, and every operator will get checkpointed. Once the checkpointed reaches the sync, the job manager knows that the checkpointing is successful in this man. Then it triggers a kill job, basically kill switch basically to the all the operators. So all the operators now running will be killed, because once you have a checkpointing information, and checkpointing information also contains the offset of the sources. This offset can be, for Kafka, this can be like a partition based offset. For database, it can be a row number, right? Exactly once guarantee, or at least once guarantee, is defined by how is your connector is written. If your connector offers exactly once guarantee or at least once guarantee, based on that, your job will offer those guarantees. For example, right, like for Kafka, you can always say that, hey, for this checkpoint, I have read till offset X, but do not consider any messages after this point. So that when the job starts from that checkpointing, it will start reading from that offset to consider it. So at that point, you get exactly once guarantee. For databases, similarly the same. It reads through the write ahead log file, basically, that is defined in your database, if it is configured. If it is not configured, then it is at least once guarantee, because it will try to scan through the database. That's how the Flink like connector, JDBC connector is defined. That's how the things works, basically on that note. And and so you see, right, like every job that or application that you write, guarantee is defined by your source connector and the sink connector. Is your sink connector is also supporting exactly once guarantee? For example, if you are writing to the Kafka, your checkpoint will know that, hey, till this offset it is written, so you can override it, lock compact it, or you can append it in the new append it to that. Also, right, like the sync will also, right, if you are having append only mode, or you are having merge into operations. So for databases, if you are configuring for merge into, then it will just go and override with the latest data. It can give you exactly once guarantee, but if you are not, if you are just doing append only, it can lead to at least once guarantee, basically. And there are some connectors where you get only at most once guarantees. For example, like it is with Cassandra, I guess, which is you can get at most once guarantees in a row. So yeah, this is how the Flink Kubernetes autoscaling works. So autoscaler is nothing, just a like algorithm based like Java, you can say pure Java application. It's not even an application, it's just a plugin where all this logic, all this computation algorithm is defined, and that is defined in a manner that configures with this configurations and reacts to those configurations. And once this configuration is done, it gives you a simple next parallelism value. And once this next parallelism value is found, the Flink Kubernetes operator, or your Flink Yarn connector, basically, right, Flink Yarn will trigger this rescale with the new parallelism, which will be accompanied by a pseudo like idempotent operation. Either it gets the successful checkpointing, starts with the new parallelism where your checkpointing data gets distributed to the multiple operators, if it is distributable, with your maybe hash map or maybe RocksDB as a state backend. Yep. So this is on a very high level and interior details of actually Flink Kubernetes operator, how it works. And yep. So there are heavily used case. So Flink Kubernetes, like autoscaler was introduced in 2022 as a proposal. Then it was like contributed from like a PMC member of Flink. Then initially when it was contributed, it was tightly coupled with Kubernetes operator. I worked on this to basically carve out and make it as a modular so that it can be used for Yarn at that time, basically. And then now it is so pluggable with a support to the database, support to the RDBMS, or even a file storage, so that you can run this mm, auto scaling, identify, or more, you can train, you can have plugin of your models also, so that they can feed in information and change or like plug in with this auto scaler and then connect it with your any operator that you are using for scaling the uh, Flink basically. So there are few use cases like Airbnb is heavily using autoscaler because of their load patterns, and they have also added like some kind of plugins to with this autoscaler in-house, and they are using it. Razorpay has a great story, basically how they were able to save a lot of money or like on the resources just by having this auto scaler which scales based on the workload and scales down based on the workloads. And there are many more. You can just search on it, and or you can go through the mailing list of Flink and you can find out all those things. Yep. Thank you so much, folks. This is how. Uh, any other questions? How can get the replay, please?
Okay, so for the replay, in a couple of days, this video will go onto the Data Couch YouTube channel, and you can get the replay over there. Any other
okay.
questions before? All right, great, Samrat. Can you please stop sharing the screen if you don't mind?
Yep, sure.
Thank you. All right, so before we conclude, I would request everyone who is participating in this wonderful webinar by Samrat to please take a moment and complete the feedback form that has been shared with you in the chat. Your feedback is invaluable in helping us enhancing future sessions as well as requesting SMEs such as Samrat to come back for more sessions. And before we go, I would like to extend my deepest thanks to Samrat for delivering such an informative and engaging session today. I trust that you all have found the insights as valuable as we did. For those who missed any part of the session or wish to revisit the material from today's session, a recording would be available on DataCouch's YouTube channel. The link to the recording will be shared on our social media channels and in our monthly newsletter that is available from LinkedIn. If you have any further questions or would like to explore additional resources, please feel free to reach out to us at hello@datacouch.io. And to stay updated on our upcoming sessions and access more valuable content, please subscribe to our social media channels and join our meetup groups. The relevant links are available on the chat. Thank you for your participation today. We look forward to welcoming you at our future events. Wishing you a wonderful rest of the day and have a great weekend. Thank you, Samrat.